through T the midpoint of the side QR of a triangle PQR. So first of all, we need to draw a triangle PQR. So let me draw the triangle PQR here. All right. So let's mark the point P, Q, and R. So this is point P, this is point Q, and then R. A straight line is to meet PQ produced to S and PR at U, so that PU is equal to PS. So first of all, I need to select the point T, which is the midpoint of QR. So this is the point T here. And if this is the point T, we can say that the length of QT, it is equal to QR. So let's write down here, QT is equal to TR. This information is given. Now we need to extend the line PQ. All right. So let's extend the line PQ like this. All right. And through midpoint, we are drawing a line like this one, such that it says the length PU. So this is point PU is equal to PS. So this is PS. So this is the figure. Now it says if the length of the UR is equal to 2 centimeter. So the length of UR, it is equal to 2 centimeter. A straight line is to meet PQ produced at S. Okay, so PQ produced at S. So mark the point correctly. This is S and this is U. And the length of UR is equal to 2. Now angle QTS here, which is this angle, is theta, and angle UTR is also theta, vertically opposite angles. And also the length PS and PU are equal. Alright, so length PS and PU are equal. So if you consider this particular triangle, which I am drawing it separately here, so PSU, the figure is not drawn to the scale. So if I say this is point P, this is S and U. So it is given that PS, it is equal to PU here. So the opposite angle should be equal. So if I say this is angle alpha, this is also angle alpha. So represent it in the actual diagram. So this angle is alpha and this angle is nothing but that is also alpha here. So this angle, angle TUR, it is equal to 180 minus alpha. Now consider the triangle TUR. If you consider the triangle TUR and if you apply the sine rule, so I can say sine theta opposite to theta, the angle is the side is 2 centimeter is equal to sine of 180 minus alpha. And sine 180 minus alpha, opposite to 180 minus alpha, the length is nothing but that is TR here. So that is TR. So I can say that means sine theta by sine of 180 minus alpha. That is equal to 2 upon TR. And remember sine 180 minus alpha, it is always equal to sine alpha. So from here we can say that the value of sine theta by sine alpha, it is equal to 2 upon TR. Now, similarly, if you consider the another triangle, that is triangle QST. So if we consider the triangle QST or QTS, you can say, opposite to theta, the side is SQ. So I can say sine theta upon SQ. And opposite to alpha, the side is QT. So I can say that is equal to sine alpha upon QT. So I can say that sine theta upon sine alpha, it is equal to SQ upon QT. So now we have got two equations. This is sine theta by sine alpha from here, and this is sine theta by sine alpha. So combine these two equations, and if you combine these two equations, what will I get here? That sine theta by sine alpha, it is equal to SQ by QT, which is also equal to 2 upon TR. And we also know that the length QT, it is equal to TR. That is already given in the question. T is the midpoint here. So from here, QT and TR, it will get cancelled as they are equal. So I'll get SQ is equal to 2. So the length of SQ is nothing but that is basically 2 centimeter. So the correct answer for this question is option B, which is 2 centimeter. Thank you.